Hi, my name is Anna Marie Whitaker, and I attended the Physics of Breakfast lecture on November 30th, 2015. The lecture explained the physics behind the coffee ring, the elasticity of scrambled eggs, and the clumping of Cheerios. This topic was interesting as it emphasized aspects of our everyday life that I've never really paid attention to. It was fascinating to hear about it on a scientific level and understand why these common daily phenomenon occur. One thing I learned was what coffee was made up of and how spilling coffee results in a coffee ring where the outer edges are darker than the inner areas. Coffee is made up of oil and molecules that pass through a filter. The oil included can either be soluble or insoluble, resulting in coffee actually being a suspension, solution, and emulsion. I found it quite brilliant how a suspension of colloidal particles was used to gather data on the coffee ring effect because colloidal particles are small enough so they follow any flow and trace out water molecules as they dry, but they are big enough to see with the proper microscope. Also, I learned that when adhesive and cohesive forces act together during this effect, it results in the formation of a spherical cap. The coffee ring actually forms when the spherical cap dries because fluid flows from the middle of the drop to the edges of the drop due to adhesion and cohesion once again. One aspect of the coffee ring effect that further intrigued me was how this idea could apply to medical devices such as malaria and Alzheimer's tests. As the speaker mentioned that these devices have not been established yet, I decided to research why these tests have not fully been optimized. I discovered that while these devices had been proposed, researchers are currently optimizing the ring formation parameters and will only later explore the application of this approach toward biosensing technology. During the lecture, I also learned about the elasticity of scrambled eggs and how it changes due to protein denaturing. Although I have learned about protein denaturing in my chemistry class before, I never realized how it resulted in our eggs being cooked. Raw eggs act like liquid and have zero elasticity. Once they are cooked, due to protein denaturing and the unfolding between the hydrophobic and hydrophilic regions, they actually behave as solids and experience elasticity. One idea in the lecture that was completely new to me was the clumping effect of Cheerios. Although I was somewhat familiar with the meniscus effect between liquid molecules and a solid, I never knew this concept applied to Cheerios. Given that Cheerios are less dense than the milk they sit in, the Cheerios want to be as high as they can above the milk's surface. Therefore, two Cheerios are drawn together in milk due to the curved up meniscuses they form with milk. This same effect, I found out, is why cereal often gets stuck to the side of your cereal bowl. I was curious if this Cheerio effect applied to any other everyday situations, and I discovered that this phenomenon also occurs with the clumping of pollen particles on lakes and the large clusters of galaxies and stars that form cosmos.